All right. I want to thank everyone for joining me this afternoon for another education and training session from Paragon Films. I hope that most of you have had an opportunity to join us for the product education and training that we've been putting on for the past couple weeks. Our hope there was that we were bringing you some real valuable information that you were going to be able to take directly out into the field and have conversations with your customers and your prospects about the films that they are using. And today we're going to focus specifically on equipment. And the reason we wanted to do a presentation that specifically focuses on equipment is because what we find when we're doing film audits is that we actually spend a much smaller percentage of our time focused on the film that we're going to bring to a call. And we spend a lot of time when we're actually physically making that call, monitoring and watching what equipment is doing and looking for ways to optimize that equipment, and just in general, making sure that that equipment is running at its peak capacity. So we're going to take a look at quite a few different aspects today. And this is just going to be part one of a multi-part series in terms of equipment training. So we're going to get into detail on some of the other portions that we don't cover in this session. So if you feel like there's something missing, just wait for the next round, and I'm sure we're going to get that topic covered as well. But a few things we're going to be talking about today. In this first round, we're going to just identify briefly some types of stretch wrapping equipment, identify those key components involved. We're going to talk a lot about properly loading film, and this is something that we feel is very important because we still see it done incorrectly quite frequently when we're out there making calls. We're going to talk about film carriages, and we're going to talk about the major components there because it's really important for us to understand what's going on with the film carriages and those major components involved. We're going to talk about photo eyes, film clamps, and wipe down arms. Those are all kind of secondary systems that can have major impacts on the way our equipment is running. And then, of course, we're going to give you some of those common problems along with solutions that you can be working on while you're out there in the field, because we really want to be addressing those minor issues in real time if we can, and making adjustments and corrections to equipment along with making suggestions to our customers about how they can be optimizing that equipment to run film. We're going to talk quite a bit about pre-stretch and on-pallet stretch, and for those of you that have participated in 5-star training, I'm hoping that you're already going to be familiar with those two topics, but we're going to go back into detail on those today. Then we're just going to briefly talk about what we do when we're out in the field. So let's just start by identifying a few types of equipment. So you can see there from left to right, we've got a ring wrapper, a rotary arm, and a turntable. So on that ring wrapper, some people call it a ringer. We typically see these in our very high throughput applications where speed is key. A lot of these ring setups can run at 60 RPM, sometimes higher. So we're going to see these at our operations where throughput is one of the most critical factors for them, and they need to get loads wrapped and moved along as quickly as possible. And sometimes you'll actually come across these ring setups that have 2 separate film carriages so they can wrap even more quickly. Second there, you can see we've got the rotary arm. Sometimes people call those straddle arms or swing arms. We see these pretty frequently, especially when we've got lighter weight loads that can't be put on a turntable because the load is in danger of falling over if we put any rotational force over it. So we've got the rotary arm that will move the film around the load, giving us that load containment without endangering knocking the load over. Then on the far right there, obviously we've got the turntable, which we see most commonly. This is the least expensive type of equipment, most accessible for our customers, especially if they are just starting to use machine film. These turntables can be outfitted with all sorts of features. You can see the one pictured there. has a wipe down arm and a film clamping system on it. So we see these in all sorts of different configurations when we're out there in the field. Next up, we've got an Orbital, a fully automatic turntable, and a fully automatic rotary arm. Now on that Orbital, sometimes we see these where customers have a different need in how they're actually putting compression on their load. They may need to have compression from top to bottom, so that Orbital is going to give them that option because it's going to wrap the four sides and give them that nice tight compression from top to bottom. And then sometimes we see these in line with something like that fully automatic turntable, where they can then go on to wrap the remaining sides of the load, and they actually get coverage on all 6 sides of that load. So we may see this in applications where they are shipping product that is very expensive and damage is just not an option for them in terms of losing product in transit. So they're wrapping all 6 sides of the load, and they need very high compression on all sides. And then looking at that fully automatic rotary arm, again, we may be dealing with a customer that's got lighter weight product, or throughput is still important for them. Maybe they don't need to move quite so fast that they need a ring wrapper, but those rotary arms will usually go up to about 35 RPM. So they can wrap much more quickly than say a turntable could, because most of those are limited to about 12 RPM. So before we go any further about components or properly loading film, I just want to reiterate why the whole piece on equipment. And the reason that talking about equipment is so important for us when we're dealing with stretch film is because it's really our responsibility to be out in the field and be the ones that are educated on the equipment. Because again, we spend so much of our time when we're on a film audit focused on the performance and optimization of the equipment itself, and much less time is spent focused on the products as far as which film we're going to bring, because we can usually determine that in advance. So getting equipment optimized, making sure all the systems are working the way they're supposed to, making sure preventative maintenance is being done on our customer's end. This is really the only way that we can be the effective packaging consultants that our customers depend on. And this is the only way that we can really go in and optimize both process and performance in terms of film. So you can see on that diagram, we've got some of the components on a turntable identified, and we're going to get into detail on a few of those. We're going to talk about film clamps. We're going to talk a little bit about wipe down arms. We're going to talk a lot about that film carriage coming up, but we're going to start with the basics here, and we're going to talk about properly loading film. So again, the reason that we feel it's important even to address this topic is because we still see it done incorrectly fairly frequently when we're out there making calls. I was in an account recently that had about 5 rotary arm machines all in line, so they were all connected to conveyor systems. And on each one of those rotary arm carriages, they had written in black Sharpie marker that the arrows were supposed to be loaded down on that incumbent film. And after a little bit of investigation on each piece of equipment, and we went through these steps, and we'll talk about those in a minute, but after we did our due diligence, we found that even with the incumbent film that they were running, the arrows being loaded down was the incorrect way for that film to be loaded. So there's all kinds of ways that this happens. You may get a sales rep in there that gives bad information mistakenly. You may have a maintenance operator that determines the film runs better when the arrows are loaded in a certain way, but these are really dangerous paths to go down with our customers in terms of always relying on them to be the authority on their own equipment, because the reality is it's not their job to be the authority on this equipment, it's our job. So what we're going to do when we go on any film test is, after we've watched the incumbent film run at least one, but hopefully multiple cycles, the first thing we're going to do when we go and investigate that piece of equipment is make sure that the rolls of film are being loaded properly, and the steps are fairly simple. So the first thing we're going to want to do is determine where the cling is on that film. And this is not universal to all manufacturers, and it's not universal to rolls that have arrows on them. You're going to have to go determine where the cling is and do that quick test that we've all done, and peel off a few feet of film, slap it together in between your palms, and determine if the cling is on the inside layer or the outside layer of that film. From a Paragon manufacturing perspective, we manufacture one-sided cling film, and that cling is always going to be on the inside layer. But there are other film manufacturers that they may load their cores onto the mandrels in the opposite direction that Paragon does, or mistakes are made in manufacturing and the cling ends up on the wrong side of the roll. Especially if we're dealing with something like a blown film and we're not aware of that. Blown film is intentionally manufactured for that cling to migrate to the outside layers. So this is just one of those things that we can't assume that all things are created equal. So we need to do that quick check and determine where the cling is. So the next thing we're going to do is, when we were initially evaluating that incumbent film, we should have been taking note of the rotational direction of either that turntable, that rotary arm, or that ring. And we want to make note, is it rotating clockwise or counterclockwise? And this is not going to be the same for every piece of equipment. And it's not even going to be the same for every piece of equipment from a given equipment manufacturer. So we need to make sure that on each call, we're taking note of what direction that film is rotating around the load. Is the turntable moving clockwise? Is it moving counterclockwise? Same thing for the rotary arm, same thing for the ring wrapper. Now, taking that cling and that rotational direction into consideration, we next need to go to the roll carriage, and we need to inspect the roller pattern on that roll carriage to see which way the film is going to pay out of that carriage and which way that is going to orient the cling by the time it gets to the load, because ultimately we want the cling to always be on the inside layer up against the pallet or the product. So this is going to change depending on what the thread pattern is of any given carriage, and we've got W patterns and we've got S patterns that we're going to take a look at in a second. But we need to be doing a physical examination of that carriage to determine where the cling is going to pay out by the time it hits the load. So we've got, where's the cling? What's the rotational direction? What's the thread pattern? Is that going to put the cling up against the load when we wrap? And that's what's going to tell us, do we load arrows up or do we load arrows down? And this will change, like I said, on every piece of equipment. So we need to be checking every time we're making a call. So here's a quick look at a W pattern carriage versus an S pattern. And you can see on that W pattern carriage what we call an easy thread gate. These are very common out in the market today from many different manufacturers. And when you close that gate and those pinch rollers line up with those drive rollers, the film feeds through in a W pattern. So as the film passes through here, you're going to be getting kind of a W that film is creating. It's coming into contact with those drive rollers as it passes through. And then over on this side, we've got an S pattern. Now these you have to manually thread. One of the benefits of this S pattern is as that film comes around and makes this S, you're getting a much higher degree of contact between that film and that drive roller. And that is going to help us in our pre-stretch. We'll talk more about that in a minute. But just note, you get that nice S as it flows through that S pattern carriage and that high amount of surface contact with the film against the roller. But again, depending on how these carriages are sitting on the tower or sitting on the rotary arm, and with that configuration of the rollers, you're going to need to visualize or thread some film through and determine where the cling is going to end up when you're loading that roll. So now we're going to move on. We're going to start talking about some of the carriage components and why it's important for us to address these before we start testing the film that we're proposing to our customers. So you can see here on this W pattern carriage, we've got our 2 drive rollers. We've got pinch rollers, which are aluminum, and those 2 on the outside. From certain manufacturers of equipment, those pinch rollers are actually going to be connected with springs and hinges. And it's important for us to verify that those springs and those hinges still have good tension. So when you close this gate, those pinch rollers are actually nice and snug up against the side of that drive roller. And that's something we do a quick field test. We'll pull the film out of that carriage, we'll close up that gate, and then we take a flashlight and we run it in between that pinch roller and that drive roller. And you're always going to see a very small amount of light. But what you don't want to see are really large gaps where you're seeing a lot of light from your flashlight come through, especially if you're seeing a really inconsistent gap. Maybe it's really wide at the bottom, then it narrows at the top. We want those to be nice and uniform and snug all the way against the side of that drive roller, because those are holding the film against that drive roller, and then as it passes through the carriage, we're getting our pre-stretch. So the springs and hinges, we may be able to adjust and address those in the field while we're on the call, or this is something we can point out that they can have maintenance internally come in and fix. But again, doing this analysis and seeing what's going to be impacting film performance when you're doing a film audit puts you ahead of the game, and it stops you from being in a situation where, for whatever reason, unbeknownst to you, your film doesn't seem to be running as well as the incumbent film. So that's why we're taking a look and identifying all these potential issues before we even begin testing. So we've obviously got the door and gate here. We're going to talk briefly about these photo eyes and how they actually work. And now we're going to take a peek under that cover. So this is what it looks like under the cover of a film carriage. And in this example, we've got a film carriage that is driven by gears. You can see 2 gears here, and belts. You can see the black belts. So some manufacturers use gears and belts. Some equipment manufacturers use sprockets and chains. We're going to look at some pictures of a sprocket and chain configuration here in a minute. On any piece of equipment that has sprockets and chains or gears and belts, this setup is what is giving us our pre-stretch. There's a motor that we can't see in this picture, but the power from that motor is being transferred to this drive gear by this lowest belt here. And that gear is then transferring its power over to this secondary drive gear over here. And that is what's connected to both of our drive rollers inside the carriage. So the ratio between these 2 gears and the power from that motor and the size of our drive rollers down in that carriage, that is what is giving us our pre-stretch percentage. And we're going to talk about calculating that before we end this session. But what's really important for you to know and really important for you to take away is pre-stretch is a mechanical function of the equipment, and it's what's happening here. So there is no way for you to go to that control panel and change the force setting or change the film tension setting, whatever it's called on that particular piece of equipment. You can't go change that knob or change that setting and affect the pre-stretch. You're not doing anything to pre-stretch when you mess with the control panel on a piece of equipment like this, because pre-stretch is a mechanical function of the equipment, and it can only be changed if you physically go in here and you start changing out the size of these gears, or you go into the carriage and you start changing out the size of those rollers. So there are a few equipment manufacturers in the market today that do manufacture pieces of equipment that instead of gears and belts, they have independent servo motors that drive each one of those drive rollers. On those pieces of equipment, it is possible for you to change the pre-stretch ratio with a setting on the machine. But the vast majority of what you're going to run into out in the field are going to be these mechanical configurations where the only way for us to actually affect pre-stretch is to go in and change out gears or change out rollers. So that's something really important for you to know and important to internalize, because you will come across customers that want to talk about pre-stretch and turning up the pre-stretch setting on their machine, and unless they've got one of those select types of equipment that can actually do that because it's got those servo motors, there's no way for them to change their pre-stretch unless you actually have your service tech come in and change out those gears. And then also on this particular piece of equipment, this film payout is managed by a dancer bar and an analog sensor. So you can see the dancer arm cam is right here. It's this triangular shaped piece of metal, and this is our analog sensor. So this is what is telling the carriage how quickly to pay out film, and we're going to touch on those a little bit more here in a second. And then the final thing I want to note is this belt tensioning device, this little black wheel back here. So that is keeping tension on that belt. And those are extremely important because we come across a lot of loose belts in the field, or that tensioning device may be in the wrong position. It's ideal for that belt to have good tension on it, so you're getting an optimized transference of power from that main drive gear over to that secondary one. So we're going to want to be checking for the components underneath the cover of the carriage, and we're going to go through a list of what we're going to be looking at here in a second. So overall, in terms of the film carriage and the components, what we're going to touch on in the next few slides are going to be those drive rollers and pinch rollers. We're going to talk about dancer bars with the analog sensor. We're going to talk about load cells. We're going to talk about the difference between the drive chains and belts. We're going to talk about the gears and sprockets, and then we're going to touch on the photo eye clamping system and wiper arm system. So during the time that we're doing our analysis on the equipment, prior to ever thinking about running our film, we're going over to the carriage, we're popping off that cover, and we are looking at those rollers first and foremost, because this is what we see most commonly in the field as far as having issues. And now these are not major, but they may require a call from a service tech if we need something replaced. But if you look over on the right-hand side, you can see something that I know we have all seen when we're out there in the field, and we've got the rollers with the cuts on them. So we know that we get a film cycle that goes bad, the film snaps back into the roll carriage, wraps around these rollers a bunch of times. The first thing the operators do is go in there with their utility knife and they start hacking away, because all they want to do is clean that film off as quickly as possible so they can get back to their day. And they do the same thing on the aluminum rollers when it winds around those. And what they've effectively done is created the potential for many more problems in the future than they would have solved by getting that film off so quickly if they would have just taken the time to actually unwind the film rather than cutting it. So we see these cuts, and on those aluminum pinch rollers, those cuts cause burrs. We see these drive rollers worn. Depending on the manufacturer, these drive rollers are coated in some sort of rubberized coating. Some manufacturers offer them in a cut-proof sort of formula that we do see out there, but all of them over time will eventually become worn. And when they're worn enough, they won't effectively be able to help our film in terms of the pre-stretch that the machine is designed to deliver. So film will start to slip through the carriage a little bit more. So we want to be looking out for rollers that are worn really smooth, because those are not going to be ideal. And we can always ask our customers, how long they've had any given piece of equipment and when the last time they replaced rollers on it was, because this is something that, like the tires on your car, we want to have changed out with some frequency when we can definitely see that there's a need. So when we've got these issues with rollers, the basics that we usually see are film breaks. We're going to see an increase in film usage. Remember, I was just talking about film slipping through that carriage when you've got worn rollers. Obviously, if you're sending film through that carriage that isn't getting the proper amount of pre-stretch, you're going to have a higher cost per pallet. You're going to have lower on pallet stretch, and you're ultimately going to have more roll changes because you're going to be using more film. Now, when you've got those cuts, especially on the pinch rollers, those will cause excessive film breaks. And what happens is those little burrs on the aluminum pinch rollers will poke a hole in the film, and you will get a film break in your cycle. And I see all too frequently the propensity to say, oh, the film broke, so we must have brought you the wrong gauge, Mr. Customer. I should have brought you a heavier gauge film because that's obviously what you need for your application. When the reality is, if we would have just taken this extra 5 minutes that this investigation takes and this evaluation of the film carriage takes, and we could have seen that burr on that pinch roller, because when you're shining your flashlight inside this roll carriage, those burrs shine really brightly and you can see them right away. So in terms of being in the field, I carry 400 grit sandpaper in my test kit. And when I'm doing my check on a film carriage, when I see those burrs, it takes all of 3 seconds to knock them down with a 400 grit piece of sandpaper. When I go to do my film test, I don't have to worry about a random film break that's related to there being a cut on that roller, because I've already addressed it before I even went on to do my test. So these are the kinds of things we need to be thinking about, and the type of thinking we need to be employing when we're out there in the field, because it's not really sufficient and it's not beneficial to us or to our customers to simply go in for a film test, throw our roll of film onto a machine and let it run and just kind of have our fingers crossed that everything's going to go okay, and then do some sort of cut and weigh and then quote a price and hope that's enough to win the business. This is all a methodology on presenting much more value to those prospects and customers that we're out there talking to by being diligent when it comes to equipment. So we've got, when we're talking about those springs and hinges that I mentioned a while ago in terms of certain pieces of equipment, those can be tightened or adjusted. If we do our flashlight test, we can suggest that maintenance comes in and does that. And then we can suggest that we have our service techs come out and do some PMs on the equipment, especially if we need to replace worn out or severely cut drive rollers. So talking about dancer bars and load cells. So the dancer bar and analog sensor system is one method that is used to determine how quickly film is paid out from a carriage. And then we've got another system that works off of load cells. When we're talking about dancer bars, and we've all probably seen these are the aluminum rollers that sit the furthest out in front of a film carriage. It's typically the last aluminum roller that will touch the film before it makes it to the load. And while these are called dancer bars, we don't want to see these things dancing when we're on a film test. And again, this goes back to when we come in to do an audit, we're watching that incumbent film run at least 1 or 2 cycles before we even think about doing anything else, because the dancer bar is something we want to be taking note of. Is that dancer bar moving consistently and smoothly with the revolution, or is that dancer bar kind of all over the place, erratically paying out film? And if it is, we know we may have an issue with the film payout system, And in the case of the dancer bar, we might need to make some adjustments inside the equipment in terms of that dancer arm cam and that analog sensor. Something might be off with those. Now, that might not be something that you're going to be able to do, but it is something that you can identify and then suggest to your prospect or your customer that it's time for an equipment tech to come out and take a look, because you can see with your trained eye that something isn't quite adding up by the way the film is paying out of that system. And then when we're talking about load cells, which is a different system used to tell the film carriage how quickly to pay out film, this is usually not something, especially with the untrained eye, that anyone's going to be able to tell a load cell is out of calibration. But when we're watching those wrap cycles, if we can see that the film is paying out at an inconsistent rate, especially if you're watching the film as it turns on the carriage, the roll of film itself, if you see a lot of starting and stopping of that roll where it doesn't sort of rotate smoothly as it's paying out, if you're working on a piece of equipment that has a load cell, that might be an indication to you that you've got a load cell issue. And that is a challenging two-person job to calibrate those load cells. So that is the perfect time to bring out our equipment techs and show those customers the values we have in terms of our equipment teams. But again, if you're not looking for this and you try to proceed with a film test, you're really not doing yourself any favors. And the odds are that someone has pointed out that a load cell could potentially be out of calibration to a vast majority of the customers that we're calling on. The odds are pretty slim that anyone's even noticed that this could be a potential issue. So once again, just by being the expert on equipment and at least knowing what you're looking at on a film test is going to show that you've got more value to that operation than some of your competitors may have. So when we've got problems with that load cell, we're going to see increased film breaks. We're going to see not enough film paying out of that carriage quick enough in some instances, and that's going to lead to the film snapping. We're going to sometimes see the opposite, where more film is paying out than needed. So we're going to end up with higher costs per pallet. We're going to need to use more film. And so all of these issues can be identified when you're performing that film audit with that customer. And we can have that trained technician come in and resolve those issues for us. Now, when we're talking about the dancer bar, that one may be as simple as turning up the force or the tension knob on the piece of equipment. Sometimes if we're not applying enough force as that film is paying out, we'll see erratic movement. So the first thing we want to do before we get too far down the road when we're in a dancer bar situation is just turn up the tension by 10 or 15% and run another cycle and see if the movement on the dancer bar becomes more consistent. If not, then we may have an opportunity for our equipment techs to come out and take a look. So let's talk about sprockets and chains and gears and belts. So I want to make note of this picture on the left-hand side. This is a sprocket and chain setup. And then this is our gear and belt setup again. But on this sprocket and chain setup, we've got a major problem with this picture. So on the gears and belts over here, here's our tensioning device sitting nicely on the outside of that belt. Over here, this tensioning device is sitting on the inside of that chain. This device should work the exact same way and sit on the outside of this chain and apply tension to it. What this customer has accidentally done is they added more gears to the inside of this loop, and they've effectively changed their pre-stretch ratio by doing so, by adding more gears. So this is something that they thought they fixed, but since you know what you're looking at when you're looking under the cover of a film carriage, you're going to be able to tell that customer right away in this instance that, hey, this should be sitting on the outside of your chain, because you're throwing off the pre-stretch capabilities of your equipment by having it on the inside. And that's just something that I wanted to make note of with this picture. But these are the types of issues we see all the time when we're out on film calls. So we've got problems where even maintenance maybe thought they fixed the problem, but they actually made it a little bit worse. And then not to mention in this picture, this whole system could just use a nice deep cleaning, because over time with this grime and this grit, this will affect the performance of that machine. So suggesting that PM of, hey, maybe you just want to give everything a nice deep clean once a quarter, and that's really going to impact the film performance as far as the better yield and the better usage. So that is definitely a way for us to show value. But we come across situations like this where some maintenance has been done incorrectly, but then also sometimes we'll pop the hood off of these carriages and chains will just be flat out broken or missing, and they would have no clue because no one has looked there for them. So that's something we always want to be prepared to address and just show them that, hey, you're no longer getting pre-stretch because this chain has been broken for 6 months. Now we're talking about these rubberized belts, and when we're looking at a belt and gear scenario, these belts do get old and they do start to dry rot and different things like that. So we want to be making sure that they're in good condition. These are very easily replaced, as far as these belts are pretty universal and easy to pick up. So your customer won't have any difficulty getting their hands on those and getting those replaced. But again, we want to be making sure we're checking on the condition and the tension, whether it's belts, whether it's chains. Those are the things we want to be looking at. There should be decent tension on those belts and chains. They don't need to be so tight that the gears can't move, but they shouldn't have a lot of slack in them, because if there's a lot of slack or if they're broken, we're going to start losing pre-stretch. We're going to start using more film. Obviously, we will lose our on-pallet stretch capabilities, and the customer's not going to see the yield or the performance that they would if these things were in good working order. So to tighten these tensioning systems is very easy. That can be done in the field. Cleaning and replacing is not overly difficult. But again, if this is not something that we're capable of doing or comfortable with doing, this is a great time to get our service techs involved and have them come out and do some maintenance. So when we're talking about photoelectric sensors or photo eyes, I do see there's sometimes confusion about, the way these actually work. So the photo eye on the film carriage is sending out an LED signal, and it's measuring the time it takes for that signal to return. So that's how it's measuring the distance from the carriage to the product. So these aren't actually seeing the load in front of them, they're measuring distance. So once the film carriage has reached the top of that load and is seeing over the top of it, the signal isn't returning to the photo eye, and that's what's triggering the equipment to actually start counting those top wraps. And those top wraps are whatever you've told the machine to do. If you're doing 2 top wraps, 3 top wraps, 5 top wraps, whatever you have programmed on the control panel, that's what the machine's going to count after it stops receiving this signal back. So some of the issues we see with these that are pretty common are height differences in the top layer, especially when we're working on customers that are running distribution operations where they are picking orders and their guys are running through the warehouse as quickly as possible, just assembling pallets and getting them ready to ship out the door. So the configuration of the pallet is always inconsistent, and we get a lot of height variations. Those photo eyes have a hard time figuring out what's going on when the signal is registering, then all of a sudden not registering, then registering again. So you're not going to get a consistent amount of overwrap when you've got those height differences in the top layer. And that's when it may be time to have a conversation. If 3 inches of overwrap on your loads is very, very important to you, then we need to think about how you are stacking your loads and how you're having your pickers stack their loads. And then we just get difficulties with the distance from the unit to the load. Sometimes these get to be a little bit long, and there's a hard time for the signal returning to the unit. And then a really common one we see is when we're dealing with really dark product, especially black and dark brown. If they're wrapping something that's one of those colors, it's much harder for the signal to bounce off of those colors. So in some of those cases, we need to suggest that they get a special type of photo eye that is designed to read those dark colors. So in terms of film clamping systems, the big thing to note when we're talking about film clamping systems is film clamps are part of a larger system most of the time. They're usually working in conjunction with a wiper arm and a cutting system, whether that's a hot wire or not. There's some type of cutting system, there's a wiper arm, and the film clamp. So the typical issues we see with the film clamp itself are when there's not enough film in the clamp, the film will pull out of the clamp on startup. We see a lot of breaks at the clamp on startup. We see the film not actually being caught in the clamp. So the important thing to note is, as I'm saying, the clamp itself is usually one part of a multi-part system. Timing is everything on these systems. The clamping system needs to be working in concert with the cutting system, that needs to be working in concert with the wiping system and the turntable and the conveyor system and so on. So all the timing on these things is super, super important to how well they're going to function. So when we've got excessive issues with the clamping system and we've determined it's not an issue like one of these, where the clamping surface itself is actually damaged, when the clamp looks to be in good working order, but we still can't quite get things to operate properly, we've probably got an issue with our timing. And some of these are operated pneumatically, some of these are operated electrically, but they're all based on a timing that the computer is in control of. And when that timing gets thrown off, the whole system starts to break down and you get a lot of film breaks that seem to be related to the clamp. So we just need to be watching for what's going on with the clamping system, what kind of shape is that clamp itself in. And this is really going to be one of those situations where if it's not as simple as replacing the actual surface inside of the clamp itself, if it really is a timing issue, this is a great opportunity for us to identify it and bring it to our customers and say, this is something that our service techs could get fixed for you and solve this problem by addressing the timing issue on your equipment. So now we're going to get into pre-stretch and on-pallet stretch. And pre-stretch versus on-pallet stretch, it's important to know, like we've already talked about, pre-stretch is not on-pallet stretch. So we talked about pre-stretch is what's going on with those gears and those rollers inside the carriage. On-pallet stretch is what we're actually achieving on the load. So I've already said that pre-stretch is a mechanical function of the equipment itself, unless you're dealing with one of those pieces of equipment out there that currently make up a small portion of what we see, but they do exist when you got those independent drive motors, those servo motors that are driving those rollers. But for the most part, we're dealing with pre-stretch as a mechanical function, so it is not possible to manipulate that pre-stretch by changing the settings on that dial on that piece of equipment. The only way to change it would be to physically change out gears or rollers. And then it's very important for us to know how to actually calculate pre-stretch when we're on site in the field with our customer, because they may not always know what they purchased that equipment at, or if there were any changes made to it. So a very simple example, when we're dealing with a piece of equipment that's got two of the same size drive rollers, would be we count the teeth on each one of those sprockets or each one of those gears, and we do a little bit of math, and that will tell us what the pre-stretch percentage is. So in this example, we've got 39 teeth on the large sprocket, 13 teeth on the small sprocket. We subtract those two, divide it by 13 teeth on the small sprocket, multiply by 100, and that gives us a 200% pre-stretch. This math changes a little bit when we've got different size roller diameters. I would encourage you to get involved with your Paragon rep and get involved with the 5-star training, because we will teach you how to do this math and be able to calculate pre-stretch percentage in the field, because it's very important to know what the equipment is capable of doing while we are there on a test. But this is something that we can all learn to do. and it's important to know because we need to know pre-stretch before we even start diagnosing on pallet stretch, because the relationship between those two is probably the most important point that I use when I'm in the field doing film audits. Knowing where I stand with pre-stretch and what I'm achieving on pallet stretch in real time while I'm standing there with the customer are the best two data points I have to know how much yield I'm getting out of the film, how well I'm optimizing the film, and what is the real potential for showing that customer a cost savings because I'm offering them better performance. So on pallet stretch is the percent of stretch actually achieved on the load when we've had secondary forces applied to the film. Sometimes pre-stretch is referred to as F1, so that's what's going on inside the carriage. On pallet stretch or post-stretch is sometimes referred to as F2. So knowing the relationship between those two is really important for us. You can achieve a difference in your on-pallet stretch by manipulating that rotational speed and by using that tension or force knob on the equipment. So this on-pallet stretch is something we do have direct control over, utilizing that control panel while we're performing a test. And so we need to learn how to not only calculate our on-pallet stretch while we're there with our customers, but how to diagnose whether or not we're achieving a negative, neutral, or positive on-pallet stretch. So an example of negative would be working on a 200% geared piece of equipment and only achieving 175 on pallet. If I'm getting 200% on pallet stretch on a 200% pre-stretch machine, then I'm in a neutral situation. And where I really want to be is when I'm working on that same 200% pre-stretch piece of equipment and I'm achieving 240 or 250% stretch on pallet, and I am in a positive on pallet stretch situation. That's where I want to be, and that is what I'm checking the entire time we're performing a film audit to see what sort of on pallet stretch am I achieving and what sort of yield and potential cost savings am I going to be able to show this customer. So this calculation is fairly simple. Again, I recommend you get on board with your Paragon rep and talk to us about 5-star training, talk to us about how to get involved and learning the math necessary to do these things, because I can't reiterate it too many times as far as these pre-stretch and on-pallet stretch are two of the most important factors that I'm looking for when I'm out there performing a film audit. So there are problems behind the curtain, as we say, that we are not going to deal with when we're on a call. And that's just because they are more involved than we're going to have the ability to address. And those are things like blown boards, when we've got wrong voltages, motors that are potentially going bad, needing to interface with the PLCs, things like that. We're going to need a skilled and trained technician to come in and help us out with those things, but we can help diagnose these problems if we know what we're looking for when we're dealing with equipment. And that's really the key takeaway here, is if you know what you're looking at, you're going to be able to help and provide that value to your customer and point out potential issues with their equipment that they may have no idea are even going on, but they're impacting their film performance and they're impacting their bottom line, and they have been for some time. But now that you finally got the opportunity to perform a film test, you are there to actually help solve those problems. So everything we've talked about in this presentation is what we're doing when we are performing a client analysis. And I hope all of you are familiar with the client analysis tool and the method that Paragon uses for reporting. But when we're actually talking in terms of performing a client analysis, we're talking a top to bottom evaluation of the equipment. How does it work with the film? How well are they actually wrapping their loads? What could they be doing better in their process? This is kind of the holistic view that we want to take in terms of our presentation to our customers. And when it comes to stretch film and consumable packaging, we don't want to be the ones that are just there showing them that the film will run and quoting them on a price. We're there to be the consultants and the experts on this stuff and help them to get more out of their operations and help them to find issues that they may not have even been aware exist. So we're looking at all sorts of things when we're on these calls. And as I hope you've gathered by now, equipment performance is key. So knowing the basics of it, understanding how to diagnose problems, being ready to provide solutions, that's what's going to make you more effective, and it's going to make you stand out from your competition when you're out there dealing with stretch film and making these calls, because not everyone is approaching business the way that Paragon does. So we've got a quick cheat sheet that we will gladly send out to you via PDF. You can email me or email the Paragon rep that's in charge of your area, and we'll send you a quick cheat sheet that just has a basic list of components and potential problems and then a quick solution. That's something we'll be happy to share with you. You just got to reach out to us and ask for it. Again, my name's Shawn Mitchell. I cover Ohio and the Pittsburgh area. I really appreciate you guys joining me today. Please reach out to me. You can reach out to Alan Abbott over in Mississippi and Alabama, Zach Poole in Georgia, Mr. Adam Luckin in Kentucky, or Carla Thorne. We're going to be very happy to help you guys out with this. We're going to be really excited to roll out the second portion of this training and talk more about equipment. But thank you very much for joining me today, and I hope you have a great rest of your afternoon.